This thing's still acting up on me. No, it's not. Yeah, it is. Wow. Okay. There we go. You had a table of 20 values last week, and they were talking to you about percentile, right? In other words, they wanted to know where the 91st percentile was. And the way to do it, when you have a finite number of values like that, is the way you did it, exactly. In other words, figure out what the 91st percentile number is in that list. But let's say your list was 2 million entries. In other words, let's say your list was the heights of women in the United States. It's 150 million women in the United States. Okay, let's talk adult women only. Well, you don't want to go through that and figure out your percentile because you don't want to put in 150 million numbers, right?
Mm-hmm.
But in problems like that, we assume that it's a bell curve. In other words, it's a normal distribution. And if the median height, for example, is 5 foot 2 inches, and one standard deviation is 5 inches, and I said to you, how many women in the country are, what percentage of the women in the country are less than 5 foot 7 inches tall? Do you know how to answer that?
Yeah, you take 50% and add 34.
Yeah, exactly. Now let's make it a little harder, and let me ask you, what percentage are less than 5 feet 8 inches tall? That's a lot harder, right? In other words, you knew that this area was 34%, and you know the area to the left of the mean is 50%, so that's how you got it. But if I go a partial standard deviation away, now it becomes a much tougher problem. In other words, if I go 2 standard deviations out, well, I know how much 2 standard deviations is, but this is only a fifth of a standard deviation. So this is where you use the z-score. Have you gotten to the z-scores yet?
Yeah.
Okay, well let's take this as an example. So the z-score for this is going to be 5 foot 8 inches minus the mean 5 foot 2 inches and divide by the standard deviation, which is 5 inches. So what's that z-score? 1.2?
Yeah.
Okay. Now, do you have a table A anywhere that has z-scores in it?
No, I don't, because we don't have a textbook.
One thing I haven't found in this calculator is a z-table. I bet there's one in there. Do you know how to get the z-table in the calculator?
No idea.
Well, what the z-table gives you, if you find, in other words, I'm looking at the z-table. If I look at 1.2, it tells me that 88.49% of the curve is to the left. of a z-score of 1.2. In other words, if I erase all of this and I left the thing down at the bottom, but if I want to know the area of this curve right here, my z-table tells me, based on this z-score, that 88% is to the left of 5 foot 8 inches. And obviously, a taller woman, like 6 foot tall, would have a z-score that was like 2 standard deviations away, precisely. But you don't need a z-table to do whole standard deviations. In other words, as long as you're exactly 1, 2, or 3 standard deviations away, you can figure it out based on the technique you gave me for 5 foot 7 inches. But if you're in between standard deviations, which is to say, if your z-score is not a whole number, if it's a decimal like this, then you can't assume that it's 1/5 of that area. In other words, this area that we're talking about right here, that is between 5 foot 7 and 5 foot 8. We know that that's 1/5 of a standard deviation, and we might even know what this whole area is. You know, if I go out 2 standard deviations, well, that second one is what? I forget. Let's see, it's 68%, it's 95%, and then it's 99.7. So as long as I have a whole number for a z-score, I can figure it out. But if I got a partial number, that area from 5 foot 7 to 5 foot 8 is not 1/5 of that area. That's not a straight line, that's a curve. So that actually is a calculus problem. When you're trying to find area under the curve, that's integral calculus. So last year, when I was working with you guys on this normal distribution, I knew that none of you had calculus, so I didn't know how to do 1/5 of a standard deviation. I just assumed that you took 1/5 of that area. Well, that's not the way they do it. And what they've come up with, in order to teach statistics to people that have not had calculus, they come up with this z-score and z-table. That's really its only purpose. Because anybody that's had calculus is going to be able to find this area under the curve by taking an integral from one limit to another. But if you haven't had calculus, then this z-score and these z-tables are the only way to really answer those kind of questions. And I was confused last week because you had a list of 20 values, and I was trying to use the z-score on them to come up with the 91st percentile. And you can if you assume that it's a normal distribution. But in the case of your 20 numbers that you had, that really was not. Nowhere did it say it fit a normal distribution. It just gave you 20 numbers and said which number is at the 91st percentile level. And so you were able to do it a totally different way. But like I said, if you had 150 million values, like the women's height in the United States, you wouldn't be able to do it that way. You would have to assume that it was a normal distribution, and as long as they gave you the mean and the standard deviation, then you could figure out whatever number they wanted to give you. They wanted to say how many women are under 6 foot tall, you could do it based on the z-score, and so forth and so on. So I wanted to at least clear that up, and mainly I cleared it up for myself. I'm not sure you were ever confused, but I appreciate the session last week. I definitely learned quite a bit about the difference between finding the percentile on a very small list of numbers and using The z-score on a normal distribution, they're not the same thing. They're different things. And you have to use z-score when you have so many numbers that you can't put them in a table. In other words, there'd be no way for you to do the problem of the heights of the women in the United States unless the problem also said it fits a normal distribution, which it actually does, and somebody actually does know what the mean and the standard deviation of that is. I was guessing, I'm probably off a little bit. I guessed 5'2" is the average height and 5 inches is the standard deviation. Probably not 5 inches. But so if you're dealing with a ton of numbers and they tell you that it's a normal distribution, you have to do it this way. And this is the way you'll have to do it the whole year. In other words, no matter at what point in your year they ask you a question like this is the way you want to do it. Now, the question is, how do you get table A? Table A has got to be in this calculator. I'm going to find out before our next session.
Okay.
Because that's something you actually need. I'm real kind of shocked that they haven't given you a table A. It's got to be in the calculator. Otherwise, they would have given you a table A, especially if they've already talked to you about z-scores. Because z-score doesn't have any meaning unless you have a table to go with it. So I'll do a little research. I've actually figured out how to do all kinds of things by just going to YouTube and searching TI Inspire statistics. And boy, it gives you all kinds of YouTube videos that are very instructive. Statistics is going to be a little different to tutor, I'm realizing, than math. Like I said, it's not pure math. Now, one thing I'm kind of expecting your teacher to do is to jump to probability probably before my book gets to probability. Has she indicated anything yet as to when she's going to get into probability?
I don't know.
Now, probability is a pure math. And statistics uses a lot of probability. Statistics is not a pure math. It's a science and an art. But probability is pure. And it wouldn't surprise me at all if she wanted to get you guys through the probability part of this course, which is maybe a third of it, at least in my book. It's a third of the book, but it's in the middle. It's the middle third of the book. So it may be that you won't get to probability till Christmas, but she may jump ahead. And that's fine. I'm ready to deal with probability. When you get to the probability section, then it'll reflect a lot more conventional tutoring. You and I have done probability before, and it unfolds just like a normal math tutoring session, whether you're doing algebra or geometry. But statistics, not so much. Statistics is more language based than numerical based, as surprising as that might sound. In rereading the statistics book a second time, I'm realizing that it's not so much about formulas and numbers. It's about the English interpretation of a set of numbers. That's what it is. But it's really not numbers based. It's word based and idea based. And, 95% confidence interval based, things like that. So there'll be a lot of sessions where a tutoring session will be quite helpful to you. And there may be some sessions where we're just talking words and concepts the whole half hour. Okay? So I'll let you go now. I'm glad you didn't have anything tonight to cover because I wanted to clarify why I was confused a little bit last week.
Yeah.
But like I said, if she doesn't jump to probability early, then I don't need a lot of warning on anything.
Okay.
But if she jumps to probability next week, just give me a heads up early in the week and say, we're into probability now.
Yeah, we'll do.
So
looks like I'm also going to be taking this class for college credit as well. So.
This is AP statistics?
AP is second semester, but there is a concurrent enrollment option for first semester as well.
Truly? Really?
Yep.
Is that new? I've never heard of that.
I don't know.
I thought you had to take an AP course and pass the AP exam in order to get the college credit. But not so, huh? Now, you said the second semester was AP statistics?
Yep.
And will you take an AP statistics exam at the end of the year?
Yep.
And that's what you'll have to pass. And I think 40% of the people, they do it on a curve if it's like calculus. With calculus, to pass the AP Calc exam, you have to score in the top 40th percentile. It's graded on a curve, and then you pass it. So I imagine they probably do the same thing with stats. Well, that's terrific. That's terrific. Anytime you can get an AP college credit. Do you know where you're going to college yet?
I'm still applying, but I'm hoping for CSU.
Okay. I got a lot of students that go to CSU. It's very,
Awesome.
That's funny too, because I get almost no students that go to CU, at least not CU Boulder. I'd say 10% of my students go to CU Boulder and 80% of them go to CSU, or at least 8 times as many go to CSU. Maybe it's the only in-state college that they can get far enough away from home.
Yeah.
Well, it's a little bit of a joke, but there's probably some reality in that.
CU Boulder's farther away from most kids.
Not than CSU. Oh, you wouldn't go up to Fort Collins?
No, I'm saying that no, I want to go up to Fort Collins. I'm just saying for a lot of kids, Boulder's farther away than Fort Collins.
Well, not my students, because my students all live south of Boulder.
Oh, yeah.
So, but yeah, all my students around Denver, CSU's a full hour drive or hour and 15-minute drive up I-25. I actually used to live in Fort Collins for about 3 months when I was younger. So, nice town, actually. A very nice town. I would have really enjoyed going to CSU myself. In fact, I tried to get into the graduate school program there in psychology, and I never ended up going there, but I would have enjoyed it. It's a real pretty campus and a real pretty town.
I love it there.
Yeah. All right, Cole, I will let you go and talk to you next Thursday.
All right. Talk to you next Thursday.
All right. Bye-bye.